Hey everybody, Mr. Fortin here. Homework tonight. So you have 4 homework problems that are assigned from the problem set, but you also have these 2 classwork problems, which some groups did because they were, they kept going and that's fine. Other groups were taking notes down and sort of doing the class along with me. That's kind of fine too. So, normally, probably the majority of groups get to these ones. It's okay if you didn't because I'm going to do them right now with you. Okay, so you got to do these 2 problems here, 423 and 424. You can do those directly on your classwork handout today. And then just maybe let's pull it up for a second here. You got your homework, which is the 4 problems out of the textbook here, 425, 426, 427. So I'm going to bold here so you don't forget. You got to finish your classwork for sure as well. And that's what we're going to do in this video. Okay, check it out here. 423, you're watching this video because you want to do it with me here. Another word problem. A set of 2 or more equations with the same variables is called a system of equations. We've talked about that quite a bit in class so far. There it is. It's defined out for you. A system of equations is a set of 2 or more equations with the same variables. Okay, so that's it here. That definition has been presented to you. Hopefully you know what we're talking about when we talk about a systems of equations the rest of the chapter. 2 or more equations with the same variables. Anyways, when you're set this 2 equations equal to each other, like Renard did in problem 421, you're doing something called the equal values method of solving a system of equations, okay? What the equal values method is, in Renard's problem, remember that was it. Here, let's go to the board here. Let's check it out here. Renard's problem, equal values method. Remember, he got them to equal values. Does this look familiar to you? Right, equal values method. Okay, so Renard's problem with the taffy, there were 5 more bags of taffy than there were of caramel. So that's why we have t equals c plus 5. And then remember, we have t equal to something, and we had that second equation. The second equation was something like 8t plus 16c equals 400. If we solve that equation for t, okay, meaning we had that second equation, if we get it in the form t equal to something, what did we do with these equations? That's right, we set them equal to each other. That's what this is talking about here. We're using the equal values method when you set the 2 equations equal to each other, and then you freaking solve it, right? I can set this equal to each other because I know if t equals c plus 5, and I know that t equals, and then remember we had t equal to something here. What do you solve for? You got negative 2c plus 50. What I can do is I can take c plus 5, set it equal to negative 2c plus 50, and then, yeah, I can solve for c right away. Then once I have c, I can go back to my original equation, solve for t. Okay, so that might have been a lot for you in class today. It's kind of a lot, just the beginning of the chapter. So let's take a deep breath. Let's do this one together. Question 423. It says here, there are 21 animals on Farmer Cole's farm. I like that because they don't say a word here, but the thing that I gather from this, the thing that I see is that this is a total. Okay, this is a total. There's a total of, right? Well, we can kind of read between the lines here. A lot of times you want to see buzzwords, the ones that I've been trying to point out to you in class here. Total, well, that's going to be the total quantity. That's the whole thing's going to be equal to. So I might even just set this up right now. There's a total of 21 animals on Farmer Cole's farm. So I know that I have one equation that's going to be equal to 21 because there's a total of 21 animals. And I know there's a total because it just says that that's how many there are here. So I'm inferring that this means the total. So total, right, means put the equals, set something equal to that. All sheeps and chickens. If the animals have a total of 56 legs, how many of each type of animal lives on his farm? Write a system of equations and use the equal value method to solve it. Be sure to check your answer, okay? Let's start the system of equations. Instead of writing our first equation here and second equation here, let's maybe define our variables real quick, okay? What are we being asked here? How many of each type of animal lives on his farm? Well, all sheep and chickens here. So to define your variables, a lot of times you look to the question being asked in the problem, okay? How many of each type of animal lives on the farm? So that means I'm going to want a variable for each type of animal here. So we have all sheeps and all chickens, okay? So I'm going to let S equal what? Units? No, I don't need, I'm just counting them up. Let S equal the number of sheep. And let me define my other variable that I'm going to write my equations with. Well, chicken, what can I do for chicken? Ah, yes, you thought of it. Fantastic. You can do C for chicken. Let C equal number of chicken that live on the farm. If I have 21 total animals that are all chicken, and all sheep. Okay, what's an equation? Sorry, there were 21 total animals. Where did the total come from? 21 total animals. Well, I take the number of sheep I have. I take the number of chicken I have. How does it get to 21? What's the mathematical operation? Well, yeah, number of sheep plus number of chicken. Well, that equals the total number of animals, of which there are 21. So here, my equation in this is just going to be S plus C is equal to 21. So, right, what I have here, I kind of described this to you in class. A lot of times your equations, you're going to have a total quantity equation. Total quantity. So here's my total quantity equation. What's my total quantity? 21. Well, I can add how many of the individual parts I have. I got some sheep, I got some chicken, add them together, get my total quantity equation. How do the total quantities relate to one another? Well, I add the two types of shapes I have together, and I know there are 21 of them. I got that equation. Is that a system of equations yet? No, it's not. A system of equations has two or more equations that share the same variables, so we need to keep reading the problem. We need to come up with another equation here, okay? If the animals have a total of 56 legs, oh, interesting. 56 legs. So a total, I'm going to set this equal to 56, and it's not going to be S plus C equals 56 because we normally have 21 of those animals there. Well, we got to think about how many legs we have then. Well, per every one sheep, how many legs is that? A sheep has 4 legs. Hoping you know that, because you kind of have to know that to do a problem like this. So if there are 4 legs per sheep, okay, I'm going to write 4S. I take the amount of sheep that I have, I multiply that by 4, because each sheep has 4 legs. That gives me the total amount of legs that are just sheep legs in this whole business. Okay, can't be any more than 56 legs total, because total number of sheep, 4S, plus what? How many legs do chickens have? Well, the chickens, they have two little wings right there. 2 little wings. Have you ever eaten chicken before? What do you have for legs? Then you have the 2 drumsticks, right? You got the two legs here, so it's just 2C. And there we have it. We have our equation right here, okay? What's the method I'm going to solve this? This is the equal values method, okay? Equal values method. So what I'm going to need to do is I'm going to need to solve for one of my variables. And I'm going to have to solve that on both of my equations here, okay? What am I going to do? Well, I have S right here, so maybe I'll solve for S, okay? You can really do either one, but I'm going to solve for S. So I'm going to get all my equations in the form S equals to something, and then I'm going to set my equations next to equal to each other afterwards and solve it, just like we did in class. So if you got it, good. If not, groove with me. Let's go ahead and get it, okay? This top equation, how can I set this top equation S equal to something? What would it be equal to? Well, S plus C is equal to 21. Well, how can I get rid of that C right there? That's right. If you were adding C to S, you simply subtract C from both sides of the equation, and then my resulting equation number 1 is going to be this. Let's maybe move it down here, okay? It's going to be what? It's going to be S equals 21 minus C. Okay, S equals 20 minus C. Okay, C, S equal to something. Can I change this one? Can I change the bottom one to the form S equals something? You sure as heck, you can bet on it that you definitely do that here. Okay, how do I do that? Well, I want to solve for S equal to something. Well, I got to get rid of that 2C there. So I'm going to subtract 2C from both sides. Okay, subtract 2C from both sides. And then I'm going to get the resulting equation is going to be 4S equal to negative 2C plus 56. Okay, and I want to get it into S equals something form. What am I going to do to both sides? I'm going to divide both sides by 4. All right, you do one operation to one side, you do the whole operation to the whole other side, and that's going to keep my equation balanced here. Okay, 4S, split it 4 ways, we're left with 1S. Negative 2C over 4, that's a little bit tricky here, but 2 is half of 4, so this would be negative 1/2 C. And then 4 goes into 56. Get a little calculator going. Sure, I'm going to calculate. I'm on a computer. I can show you that calculator thing right here. But you want to save the hard stuff for your brain. The easy stuff, you just want to get a calculator doing it. And that's 14. Okay? Equal values method. What are we going to do for the equal values method? Well, I got S is equal to something. And S is also equal to something over here. So what do I know about those two somethings? Well, they both equal S. They both got to equal each other. Something called the transitive property of equality. You'll study that in geometry, okay? So what do here? You take negative 1/2 C plus 14, and you set that freaking thing equal to 21 minus C. And then you solve for C. This is a little bit messy here. Okay. I have more negative C's down here, so I got less negative C's up here. So I'm gonna add C to both sides here, plus C. Okay, a negative a half of a C. If I'm adding a whole C to that, I get rid of the negative half, and I'm left with a positive half. Okay, I owed 1/2. I got a whole thing back. Well, then I have a half now. Okay, so I have 1/2 C. Okay, 1/2 C plus 14 is equal to 21. Okay, now I'm going to subtract 14 from both sides. I get 1/2 C is equal to 7. Okay, this is a little bit tricky for some people. A half a C is equal to 7. So then what's a whole C? Okay, half a pizza costs $7. Half a pizza costs $7. How much does the whole pizza cost? 14 bucks. Just got to double it here. Okay, so when you have that fraction there, 1/2 times by C, you just multiply both sides by 2, and that's what's going to get rid of the 2 denominator here. 2 divided by 2 is 1. We made a 1 there. Nice. So I get C equal to 7. So I'm going to have 7 chicken. Okay, and how many sheep am I going to have? Well, I'm going to go back here. I know the total amount. Total amount is 21, right? Am I right? Okay, 21 total animals. 7 are chickens. So how many are sheep? 14 sheep. Okay, 14 sheep here. Okay, so let me type in the answer so I can get this video taken care of here. So we're going to have 7 chicken and, oops, spread it on out. 7 chicken and 14 sheep is my final answer. And, you know, that's maybe a little bit hard for you guys to figure out on your own tonight here, but hopefully you're going to give it a shot. You're watching this video. Thank you guys for watching. I'll film a separate video for 424 just so this video isn't super long, because I think that went a little longer than I was expecting here. Thank you, folks. Watch the other video if you can use some help with it. Bye, everybody. Bye.